Yeah, listen, student, what we have to discuss today, you know the chiral carbon, achiral carbon. Chiral carbon means the carbon have 4 bonds. So all the 4 bonds have different molecules in that carbon is a chiral carbon. Okay, chiral carbon, and it is a non-superimposable with mirror image. Okay, non-superimposable with that mirror image of the molecules. That is a chiral carbon. Right? So chiral carbon means, for example, fluoride, hydrogen, NO2, and here fluoride, bromide, H, NO2. So here this is a chiral carbon, this is a achiral carbon. Okay, chiral carbon means the 4 molecules attached in the carbon, it is different. That is a chiral carbon. And with the mirror image is a non-superimposable one. Yes, suppose if you take the mirror image means, what is the mirror image? So Br, NO2 and Cl, hydrogen. So this one and this one is a non-superimposable one, like right hand and left hand. Okay, this carbon is a chiral carbon. And for the configuration, R and S, okay. So now only we go for the absolute nomenclature, R and S conformation for the chiral carbon. Okay, chiral carbon, R and S conformation. R and S conformation. So this one they call CAP, that is Chan, Ingold, Prelong. So all 3 people found that configuration, conformation. That's why we can say CAP. Okay, Chan, Ingold, Prelong. Okay. So R and S conformation given the right absolute configuration for your chiral molecule. So here we follow the rules. Okay, we follow the rules how we have to find one molecule is a chiral, one molecule is a R configuration or S configuration. Definitely the question will be there for your CT exam based on the R and S confirmation. So what is the first job? We have to identify the chiral center. Okay, identify chiral carbon, because sometimes you know the glucose, fructose, that kind of molecules, so many carbons are there. Therefore, the first job is to identify the chiral center, because some carbon there is no chiral center because the 2 OH group is there in the neighboring carbons. That means that carbon is a not chiral carbon. So first job is to identify the chiral center. Okay. Then give the priority. Give the priority based on atomic number or atomic mass. Okay. Give the priority. That means which one is the first one, second one, third one. We have to give the number. So that the numbers give the priority of the group attached to the chiral center based on the atomic number. You can write it elaborately, whatever you want. Give the priority based on the atomic number. Which one is more atomic number? That is the first priority. Okay. So let's think about it here. Yeah. Suppose here chloride, bromide, hydrogen, NO2. So here N is there. Okay. So chloride, bromide is maximum atomic number. So first priority. Chloride is second. Then nitrogen. Right? Nitrogen. So third priority. This is the fourth priority. Likewise, we have to given the priority. based on the atomic number. Which one is more atomic number? You give the more priority. Similar group is there means you look at the next molecules, next atom, okay, attached in the same molecule. That is the second job. Third job, after giving the priority, least priority group away from the observer. Okay, the least group, that means the fourth group away from the observer. That means how we have to view the molecule means the least priority group away from your view. That is the back side of your view.
It should be a view.
Yeah, always we have to look at the molecule in front of the more atomic number, not in front of the least atomic number. Okay, in front of the more atomic number. Therefore, the least group, the least priority group away from the observer. Okay, the least group away from observer. That means, yeah, here we given, right, hydrogen is a fourth priority. Therefore, we have to look at the molecule from here, not from here. Okay, not from here. We have to look at the molecule from here. That means in front of the more priority group. Okay, more priority group. The next step, look at the direction of the priority. Look at the direction. Okay, look at the direction. If clockwise means clockwise direction means R configuration, R conformation. If it is anti-clockwise conformation, anti-clockwise means if anti-clockwise means S conformation. Okay, clockwise means R conformation, anti-clockwise means S conformation. That's it. So we have to identify the chiral center, give the priority based on the atomic number, look at the priority direction. If the priority direction is a clockwise, you know how to write the R configuration. You write it like this, right? So this is a clockwise direction. So hence R. How to draw the S? S is you are doing like this. This is the anti-clockwise direction. Therefore, yes. Just for you to remember. Okay, your understanding, quick understanding. Or you can write it like this. So clockwise direction means R configuration. Yes, you write it like this. That is the anti-clockwise direction. That is a yes. Okay. So here some exceptional case is there. That means for the Fisher configuration, okay, here what is the exceptional case? In case the least priority group in front of you, okay, the least priority group present in the front side means we have to exchange the confirmation. If it is R means the right confirmation is a yes confirmation. If it is yes means the R is the right confirmation. To write it, I will explain later. Okay, you write it. If least priority group, if least priority group Okay, if least priority group on horizontal line, that means left and right side, horizontal line. Okay, take a opposite configuration. Take opposite configuration. Take opposite configuration. For the Fisher projection only, if the least priority group present in the horizontal line, then you take the opposite configuration, because if horizontal line means, you know, this is a top and bottom.
Excuse me, sir. Can you make an announcement? Please. Thank you, sir.
Hello guys, we are from Coding Ninjas 10x. We bring you our flagship event.
Yes, student, listen. So if the least priority group present in the horizontal line means, take the opposite configuration. That means if the least priority group present here and here means, we can look at from the back side or front side. But it is there in the plane means, we have to take a opposite configuration. Okay. Let me do the practice. You get some idea how to give the R and S configuration or confirmation. Okay.
Sir, horizontal line as in like, can you explain the last one?
Yeah, that's what. When we do the practice, then you realize what is that. Okay. Only the point, the least priority group present in the horizontal line means, take a opposite configuration. Okay. So for example, COOH, OH, hydrogen, okay, hydrogen and CH3. CH3. What is the confirmation of this one? What is the first rule says? Identify the chiral center. Yes, this carbon is a chiral center. What is the second rule? Give the priority based on the atomic number. So here carbon, here oxygen. Oxygen is more atomic number, you know. Therefore, this is the first priority. And the second priority, here carbon. That's why you can look at the neighboring atom. So here hydrogen neighboring atom, but here oxygen is a neighboring atom. Therefore, oxygen is more priority. Therefore, this is a second. And what is the third? This one. And this is the fourth one. Look at the priority direction. 1, 2, and 3. Right? 1, 2, 3. That is a yes confirmation. But here the least priority group present in the horizontal line. Therefore, the R is the right confirmation. That is the meaning of the last rule. Last rule. The least priority group present in the horizontal line, hence we take the opposite configuration. R is the right one. R is the right one for the Fisher projection only. Okay. COOH. This is the second priority. Therefore, we have to go this direction.
Sir, first priority.
First priority, this one, right? OH. Which one is attached
yes,
first
yes.
one?
Yes.
Which group, which atom attached the first? O and carbon. Therefore, O is the maximum atomic number. Oxygen is the maximum atomic number. Okay. Actually, simply you can take the opposite configuration. Otherwise, the rule is there. What is the rule means? Suppose COOH, OH, CH3, hydrogen. So here 1, 2, 3 and 4. What is the actual rule? You have to exchange this group and this group. You have to exchange this group and this group. Therefore, what we get is COOH, OH and CH3 and hydrogen. Now you give the priority 1, 2, 3. Therefore, 1, 2, 3 is a R configuration. Yes. No, clockwise direction. Okay, R configuration. This is the original way how we have to do it for the least priority group present in the horizontal line, means we have to exchange the groups. Okay, we have to exchange the group, then you give the priority, means you get the R configuration, right configuration. Because here the least priority group, downward direction. Okay, right. So maybe we'll discuss more examples, then you realize what it is. You try to work out, okay? If it is wrong or right, no issue, but you can try to work out. So for example, don't expect very simple molecule they given for the nomenclature of R and S configuration. They given a complicated example. Okay, complicated questions. So for example, you know what kind of molecules this one, suppose Br, hydrogen. These are molecules. Okay, what is the conformation of this molecule? What is the conformation of this molecule? R or S configuration? You try to work out in your note. You try to work out. If it is wrong or right, no issue, try to work out. Then only you realize your mistake. You remember the rules. What is the first rule says?
It's supposed to
Identify.
be R, but it will be S.
Work out. Here the dash way is away from the observer, right? The wedge way means it is towards your side. So already it is a right configuration only. We should not exchange the group. Why? The last rule says if the least priority group present in the horizontal line, then only you can take a opposite configuration. But here the least priority group already away from the observer. But how many number of chiral carbon is there here? How many number of chiral carbon? So here also carbon is there, but
It's not chiral.
hydrogen and hydrogen,
Yeah.
CH2 is there. Therefore, that is not a chiral center. Only chiral center is here. And here the priority. So here bromine, here CH2, CH3, here CH3. So bromine and carbon, which one is more atomic number? Bromine. Therefore, this is first priority. And here, this is second priority. This one third priority. Already this one is away from the observer. Therefore, you have to look at the molecule from this direction. Okay, from this direction. Therefore, from here to you have to look at the molecule means 1, 2, 3. That is R configuration. R configuration. Right? Anything doubt? You try to practice, otherwise in the exam, in MCQ also one question is there, in the part 3 also one question is there. Okay. MCQ they may give the very simple example, but in the part 3 they give a complicated example. No doubt, right?
Sir, wait.
Here CH2, CH3, here CH3, carbon, only one carbon is there, but here 2 carbon is there. That is more weight compared to CH3. Ethane is more weight molecule. Hence that is the second PR. Any doubt? In the three-dimensional structure they given not only the Fisher conformation, don't expect only the Fisher conformation, they may also give a Newman projection also. They also given the saucer projection also. Okay. Most probably they given only the Newman projection. I can move this one. Identify R and S conformation. R configuration or S configuration.
So this doesn't have a chiral conformation.
Yeah, no chiral center. No chiral center because here CH2 OH. Here also CH2 OH. Here one hydrogen, here one bromine. So there is no chiral center, no R and S configuration. Only the R and S configuration for the chiral molecule. Okay, chiral molecules. And similarly, yeah. What is a yeah? What is the configuration?
R. Oh no, not R.
Try to work out. Yes, this is a right chiral molecule because the least priority group away from the observer only. Only your job is to given the priority based on the atomic number. So the first priority is bromine. Second priority, here also carbon, here also carbon. But one thing you notice here the single carbon, single bond carbon. Here double bond carbon. Alkene bond is there. Here alkane bond is there. So alkane, alkyne is there. Means alkane is the first priority. Then alkane, then alkane. Therefore, this is the second priority. This is the third priority. Therefore, 1, 2, 3. Yes, confirmation. Okay. Yes, confirmation. Just you give the number, then you connect that number, you get the R or S. Only the exceptional case is the least priority group present in the horizontal line. You consider opposite confirmation is the right one. Right one. Okay. Sorry, I'm wasted next space. Not only see OH, they may given carboxylic acid also, ester also. Okay, anything. So for your quick understanding, I given OH. Maybe they given COOH also. Now, what is the configuration of that molecule? Already least priority group away. First you fix it. Least priority group is away from the dotted line. That is a shaded line, thick line. So therefore, we should not take opposite configuration. Whatever we are given, that is the right configuration for that molecule. First you fix it. Then you give the number. Here carbon, here also carbon. Therefore, oxygen is the first priority. That second rule, then now only I told you, alkene bond is the first priority. Therefore, this ring is the second priority, this is the third priority. Therefore, from here to here, what is it? Yes. S conformation. Okay, in case the same molecule, okay, instead of Br, hydrogen is there, here Br is there. What is the conformation? Similarly, here OH is there, here only hydrogen is there. What is the conformation? Opposite. Because the least priority group towards your side. Towards your side. See, look at here. Suppose you are viewing the molecule from this side. Okay. This side 1, 2, 3. 1, 2, 3 from your side. But my side inverse umbrella. Inverse umbrella. So that's why we exchange, take a opposite configuration. You can show your left hand in your mirror means it show right hand. Right? Opposite configuration. Similarly here also the least priority group towards your side means you go and look at the molecule from opposite side, back side of our board. Okay, back side of our board. Always we have to look at in front of the more priority group side. More priority group side, not least priority group side. We have to look at the molecule in front of the more priority. Just you take a opposite configuration. If it is S means the OH is there in the least side and hydrogen is there in the towards your direction means S is the right configuration. Just to take opposite configuration. Any doubt? No doubt, right? Yeah, what is the R and S conformation for these molecules? R and S conformation for these molecules. How many number of chiral center is there?
1, 3.
How many number of chiral center is there?
9, 2.
Only few are answering, others you are looking the mobile phone, you are watching some movies, even though you are not listening the class. Last table, listen. How many number of chiral center is there? 2 chiral center. This is not a chiral center because here CH3, here CH3. Therefore no chiral center. Here different group, here different group, here different. So one chiral center and here also one chiral center. Now we have to identify R and S conformation. What I told, given the priority based on the atomic number, here carbon, therefore here OH, this is the first priority. And here carbon, but here keto carbon, here there is no keto. That means double bonded give the first priority. Therefore this is second, this is the third. Okay, this is already 4. Therefore 1, 2, 3. 1, 2, 3. This side is yes conformation. Am I right? Now you can say this one. NH2 group attached. These two. NH2 group attached. What is the conformation of these molecules? the conformation of these molecules? Then try to work out and let me know what is R or S conformation. You tell me, then only we can rectify your doubts, clarify your doubts.
This is R.
This one R.
Yeah.
How many of them are conformation? You get it? You. Okay, look at this one, carbon, here NH2. Compared to carbon, nitrogen is a more atomic number first. Right? Here carbon, here also carbon. Neighboring group, here carbon, but neighboring group, here keto group and OH group. Therefore, this is the second priority. More atomic weight is there this side only, not that side, because the neighboring group is both are carbon. Everywhere carbon. But here oxygen, carbon is there, therefore this is second priority, this one third priority. Already hydrogen is there in the back side of the group board only, therefore no issue. Therefore 1, 2, 3 R, therefore S and R conformation. That's it. S and R conformation. Suppose they didn't given the carbon number means, remember, sometimes they given the carbon number 1, 2, 3, 4, 5, 6, 7. That means 6 as 5R. Like that, you give the number with the conformation. 6 is 5R. That means the fifth chiral carbon group is a R conformation. Sixth chiral carbon is a S conformation. Any doubt? So almost I am going to finish your R and S conformation. Maybe you can try to work out some more example also. With the ring. Okay, with the ring. It may be useful for you. With the ring. Hydrogen, Cl, OH, hydroxide group and a chloride group. What is a conformation R and S? What is the conformation? Think about it and let me know. What is the rule says? Identify the chiral centers. So here one chiral center is there, here one chiral center is there, right? Right?
Sir, do we consider because both are connected to CH2, that's why I'm asking.
CH2?
CH2, like those carbons.
Here,
These carbons?
CH2, CH2.
CH2.
Neighboring carbon CH2. Here there is no neighboring carbon.
Okay, so we consider that.
Look at the neighboring carbon.
Okay.
Neighboring carbon. What is the first job? Identify chiral center. Second, give the priority. So chlorine is the first priority. There is no doubt about for the chloride. And the second, here carbon, here also carbon. So leave it. And here carbon, but here carbon attached OH. Attached OH. Therefore, this is second priority. This is third priority. So now you look at it 1, 2, 3 R configuration, but least priority is there in front of you. Therefore, S is the right one. S is the right one. And similarly here also notice the first priority is OH, second priority here CH2, here also CH2, so leave it, and next is here Cl, but here CH2, therefore this is the second priority, this is the third priority. Now 1, 2, 3 S configuration, but towards to you R configuration, so therefore this is the R configuration, this is the S configuration.
Sir. Sir, this is clockwise now.
Clockwise direction R configuration, but the fourth group is towards to you, therefore S is the right one.
Okay.
S is the right one. Similarly here also the fourth group is towards to you, so therefore you take opposite, R is the right one. So S and R confirmation. Then what if here, what happened this molecule? What happened this molecule? This molecule, what is the confirmation?
This is not correct.
Yeah, no chiral center, because from here 1, 2, 3, 4, 5. From here also 1, 2, 3, 4, 5. No chiral center. This is a achiral carbon. Achiral carbon. Identify the chiral center. That is the first job. Here there is no chiral center, achiral carbon. Hence we should not give the R and S confirmation for this point. Okay. If you need more example, maybe you try to work out in your Oscar hydrogen CH3 keto group. What is the confirmation? Okay. What is the confirmation?